Polaris. So this is Polaris, one of the many stars in the night sky. But it's actually not the brightest star. It's actually about the 50th brightest star visible from Earth, but it's been known to explorers for centuries. Polaris isn't a single star, it's actually a triple star system. And Polaris A is the biggest. It's called a supergiant. To be a supergiant means you have to be a certain size larger than our sun. So in this case, the mass of Polaris A is 6 times the size of our sun. And it sits about 430 light years away from Earth. Now what a light year is the distance, and that's not time, it's distance, that light travels in 1 year. So when you think about how fast light travels, which is 300,000 kilometers per second, and you think about how many seconds there are in a year, you can use that to figure out how far light travels. And it's a pretty big distance. So 430 light years is pretty far. So during the day, sailors would use the rising and setting sun to sail east or west, and if they knew which way east and west was, they could easily sail north and south. But when the sun set, they relied on stars. Now Polaris was commonly, or still is commonly, referred to as the North Star because its height above the horizon will tell you how far north or south you are from the equator. So in order to use the North Star, you first had to locate it. And remember, it was the 50th brightest star in the night sky, so that couldn't be easy. So if you wanted to find the North Star, you need to first locate the Big Dipper. And the Big Dipper is a constellation that's part of a larger constellation called Ursa Major. And depending on the season of the year, the Big Dipper can be found high in the northern sky or low in the northern sky. In the springtime and summer evenings, the Big Dipper is going to be high. In the autumn and the winter, you would find it closer to the horizon. Now, once you've located the Big Dipper, you can find the 2 outer stars that make up the cup, the bowl of the Big Dipper. These are referred to as pointer stars because you can draw an imaginary straight line from those 2 stars, and the star that it points to is Polaris. And Polaris happens to be the handle, the beginning of the handle of the Little Dipper. So this video is really going to talk about why we call Polaris the North Star and why sailors were able to use it to navigate. So Polaris is a unique star because it's motionless in the sky. If you were to take a camera and open the shutter and allow it to take a time exposure photograph, you would get an image like this. The streaks are the motion or the apparent motion of the stars, and in the center of all this motion is Polaris. Polaris doesn't move while everything appears to rotate around it. And this has a lot to do with why Polaris is such an important part of navigation. Because Earth is a magnet, it has 2 poles, the North and the South Pole. So all magnets have a North and the South Pole. And these aren't actual poles sticking out of the ground, they're just the ends of the magnet. So the Earth has a magnetic field that originates from the North Pole and flows to the South Pole. If we were to look at the position of Polaris, it is in a direct line with the Earth's axis of rotation. That means it's directly above the North Pole. And it's not really above the North Pole, you have to remember space is 3-dimensional. But if you were able to draw a straight line from the North Pole that was 434 light years long, you would hit Polaris. And Polaris is only visible to observers in the northern hemisphere. So what was known to sailors was that the altitude of Polaris in the northern hemisphere increased as they sailed northward. This allowed them to sail at night and use the stars to navigate, because as they sailed, Polaris would get higher. And only because the Earth is round does Polaris's altitude change as the observer changes. And this only works for latitudes in the northern hemisphere. Basically, if you're an observer at the equator, which has a latitude of 0 degrees, you would see Polaris at the horizon. Stars and constellations at the horizon would have an altitude of 0 degrees, since this is the lowest position any object can have in the sky. An observer at the North Pole, which is equal to 90 degrees north, would find Polaris directly overhead. Objects in the sky that are directly overhead have an altitude of 90 degrees, so which is the highest altitude an object can possibly have in the sky. And an observer in New York City, which has a latitude equivalent to 40 degrees north, they would find Polaris 40 degrees above the horizon. So just as a basic premise, as your latitude increases in the northern hemisphere, so will the altitude of Polaris. And you can also say that if you know your latitude in the northern hemisphere, you know how high Polaris is in the sky. Let's look at some examples. Let's practice. What is the latitude of this observer? So this is a very standard regions question. You have an observer looking out through a telescope and measures Polaris to be 20 degrees above the horizon. So taking into account some of the things we discussed, Polaris is only in the northern hemisphere, and the altitude of Polaris is equal to the latitude of the observer, because it will always match where you are in the northern hemisphere. So the latitude of this observer has to be 20 degrees north, because that's the altitude of Polaris, and Polaris can only be seen in the northern hemisphere. Here's another example. What's the altitude of Polaris above the horizon in this picture? So, according to this, the observer sees Polaris above the horizon at 66.5 degrees. So, the altitude of Polaris is 66.5 degrees. Now, the latitude of the observer, because Polaris can only be seen in the northern hemisphere, is going to be 66.5 degrees north. So, general rule, if you're in the northern hemisphere, your latitude will equal the altitude of Polaris. And that is why sailors could navigate at night in the northern hemisphere and go north or south using the North Star. So, that's it for now. Thanks for watching.